Quick review of soldering, different materials. So we're going to start with zinc. And zinc is probably the most temperamental thing to solder next to stainless steel. Two different types of solder. So I have 100% tin solder, higher melting temperature, okay? So it's good for copper, good for stainless steel, not so good for zinc. The difference between the melting temperature of the actual zinc and the melting temperature of 50/50 solder is about 100 degrees. Okay, so there's a very high risk of burn through the zinc if your heat on your iron gets out of control. Okay, so with that in mind, I have a couple of different soldering setups. The express irons are way more controllable. So you can drop, once these things get to the heat that you need, then you can back off a little bit and solder, okay? The Perkio gets hot, stays hot, and it's like super hot. So I really like that for copper work. In some situations, stainless steel, but copper and lead-coated copper for sure. Absolutely will not use this iron on zinc because it gets too hot. But if you're working on any kind of material where it's sucking heat away from the iron, especially copper, then you want to use something that can maintain heat. And the Perkios hold that heat pretty well. So to get going, I'm going to start with 50/50 solder. When this drops, I'll be ready to solder, okay? While I'm waiting for that, I got a couple of choices of flux here. Red lid is for clean material, black lid is for oxidized material, and this is a good general purpose flux for just about anything. I usually start with that. You can't overflux, so don't be afraid to put it on, even while you're soldering. Because as you solder, you dry that out. So every once in a while, you have to refresh the flux. With all materials and the tip of the soldering iron itself, it has to be shiny, okay? So, see how dull that is? The duller that is, the dirtier it is, and the dirtier it is, the harder it is to solder. The only thing here we should have to do any major cleaning to is the actual zinc. Zinc comes out of the factory or out of the mill looking like galvanized. It's shiny, okay? VM Zinc puts that zinc through a chemical bath to turn it gray, and that's its natural patina. If it was allowed to weather on its own, it would take about a year or so to turn gray. So they push that in a chemical bath. So you gotta take that patina off. And get it down to bare zinc. And you want to flux or clean everywhere that you're gonna want solder to flow. So I have to clean the backside of this also. Another peculiar thing about zinc is the plastic is fairly resistant to heat. So I can leave this plastic on, and when I'm done soldering the joint, I can run solder right along that plastic and then peel the plastic, and it's a perfect joint. Okay, so don't peel the plastic until you're done soldering the joint. Okay, that solder just dropped. So that's up to temperature, especially with zinc. I don't want the heat to be runaway heat, so as soon as that gets to where I want it, I'll back that off just a little bit. Because it has such a low melting temperature, the zinc, you never want to do an overlap of more than like a ½ inch, okay? If I take typical copper overlap is maybe an inch, inch and a half, maybe more, depends on who's doing the soldering. But if I take this and I try to suck solder through that joint, an inch and a half, I'll burn through the zinc before I suck that solder through, okay? So you want to keep laps on zinc are at most around a ½ inch. If you look at some of the ornamental work in France, they do actually do butt joints. The stuff solder is so nice that you can do a butt joint like that, and it's a good joint. Okay, everything's clean and ready to go. Iron's hot enough. We'll get some flux on the joint. And you don't want to start at one end and go all the way through. You want to tack that down about every 2 or 3 inches. First thing. Second thing you want to do is make sure that this is clean. So I just want to get that fairly clean. It's pretty good. So that's what I want. I want to shine. Okay.
What'd you dip that in, John?
Just water.
Just water?
You could do like a light mixture of water and flux. It's not bad. I like to use just a wet sponge. So 50-50 solder. And again, I don't want to burn through the zinc, so I want to get some solder on there, and I want to suck it through the joint. Let it cool. So when the solder is shiny, it's liquid. As soon as it gets dull, it's solid. All right. So shiny is liquid. As soon as it turns dull, it's solid. Okay. If you were to start here and just come straight down the joint, from the heat, the metal starts to distort, and it makes soldering a lot more difficult. My general rule of thumb is that the heat follows the handle. So if I want to draw solder this way, I want the iron facing this way. Okay, I don't want the iron this way. I want the heat. I want this heat to be sucking that solder all the way to the end of that underneath of there. If you don't suck it all the way through the joint and you leave a void there, that void is full of acid, and that acid attacks the metal. So do a joint that you can control the depth of the solder. Make sure that solder goes all the way through the joint. Okay. Once you get everything tacked, just start filling in between there. Now my overlap here is about a ½ inch. So if I put the iron here, I'm not at a ½ inch. So that solder is going to stop right there. Okay. If I want that solder to go back to here, I got to take the iron back to there, get that heat back that far. Okay. Do a little bit. Shiny, it's still liquid. And as soon as it cools off and turns solid, you can move on to the next one. And again, I want the heat to be where I want the solder to go. I know my joint's about a ½ inch, so I want to be at least at about a ½ inch. Give that a chance to set up. And then move on to the next one. Get too nervous and jerky and you do that too fast, then from the heat, the metal's going to distort and it's going to pucker up on you. So give that a chance to set up before you move on. And see it's starting to dry out. You can always add a little bit of flux if you have to. cannot overflux. And the flux is the vehicle that makes the capillary action happen and actually sucks the solder through, all right? Depending on what you're doing, some people will stitch this joint to make it stronger. I don't have a problem with stitching. I try to stitch only in a situation where I have a joint that's exposed to expansion and contraction. All right, so if I'm just doing something ornamental like that, you don't have to get too crazy and too lumpy with the solder. See, that's all the way through that joint. The solder flowed all the way through that. Okay. If there was any gaps there and that solder didn't push all the way through that joint, I would have acid trapped between the two pieces of metal, and it would attack that joint. So stitching, depending on who you talk to and what country they're from, stitching is usually done horizontally. Again, you can't overflux, put a little bit of flux on it. And all you're doing is building up material to strengthen this joint. So you want to take, you don't want to use the whole iron, you just want to use the tip of the iron. Okay, I'm just doing a stitch, just like that. Adding a little material, and I'm dragging it across the joint. Okay, so some people will stitch this way. Some of the Europeans do like a drop, so they'll do that and then they'll do a little circular stitch like that. So material, do a circle, all right? Again, all that does is make the joint stronger. If it's in a place where it needs to be stronger. So I can take my iron and just run down along the edge of that plastic. Without touching the plastic. Last thing on joint, whether you stitch it or don't stitch it, is you want to clean it immediately, because again, the flux never stops attacking that. Flux never stops attacking that joint. Get any acid off of that.
That's just water you use?
Just water, yeah. You can use, some guys will use baking soda to neutralize the acid. Easy to keep a straight line. That's pretty nice. And we're good all the way through on the back side there. Okay. All right, so that's zinc. Zinc is probably the most temperamental thing on the table here.
It's gonna look pretty easy.